Welcome everyone. Let's discuss another question from GATE 2023 Biotech exam. The question says, if 1000 base pair of a double helical DNA weighs 1 into 10 raised to power minus 18 gram and the distance between two base pair given is 0.34 nanometer, the total amount of DNA in milligram we need to calculate, which is required to stretch from Earth to Moon, assuming that the distance between Earth and Moon to be 374 into 10 raised to power 3 kilometer. Now, what all information is given? The first information which is given is the distance between subsequent base pair, which is 0.34 nanometer. Remember, what we need to do is, first of all, we need to figure out the number of base pair corresponding to this number. And only then we'll be able to calculate the amount. So we all know DNA double helical strand and the distance between adjacent base pair is 0.34 nanometer. Remember, one turn of DNA has approximately 10 base pair, and the length of one turn is 3.4 nanometer, because 10 into 0.34 is going to be 3.4 nanometer. With all this information, we can frame this equation. Length of DNA is going to be 0.34 into total number of base pair. This number we need to calculate for this value. So this is going to be 374 kilometer. Will convert it into meter, 10 raised to power 6 meter. And then 0.34 nanometer will also convert that into meter, which is 0.34 into 10 raised to power minus 9 meter. Remember, 1 meter equal to 10 raised to power 9 nanometer, or 1 nanometer equal to 10 raised to power minus 9 meter. This will give you the total number of base pair. So this value is going to be 374 into 10 raised to power 6 divided by 0.34 into 10 raised to power minus 9 meter. And this is going to be total base pair of DNA. And if we'll calculate this value, this is going to be 1100 into 10 raised to power 15 base pair, or I can convert it into 1.1. I'm just shifting the values. 1.1 into 10 raised to power 18 base pair. So I have calculated the total number of base pair. Now what I need to do is I need to calculate the amount. So if you go back to the question and you can see this value, if 1000 base pair of a double helical DNA weighs, given 1000 base pair of a DNA weighs around 1 into 10 raised to power minus 18 gram. So how much this value will contain? So you have one base pair corresponding to 1 into 10 raised to power minus 18 gram by 1000, and then you have corresponding to this number, which is going to be 1.1 into 10 raised to power 18. This will get cancelled out. So the final answer is going to be 1.1 into 10 raised to power 3 gram. But we need to report our answer in milligram. So 1 gram equal to, sorry, this is going to be 1.1. If this will shift to the numerator, this will become minus 3. So as I said, 1 gram equal to 1000 milligram. So this value is going to be 1.1 into 10 raised to power minus 3 into 10 raised to power 3 milligram. This will cancel. So the final answer is 1.1 mg. So we'll get back to this question. The total amount of DNA in milligram we need to calculate from this number, and this is going to come 1.1 mg. So this completes the question which has been asked, which is the total amount of DNA in mg that will be required to stretch from Earth to Moon, and the answer is 1.1 mg of DNA will be required to stretch from Earth to Moon. I hope this solution is clear to each and every one of you. If you do have any concern, please feel free to comment. Thanks for watching the video.